A very good evening and a warm welcome to everyone from Excellent Excel. Hope you all are safe and doing well. Thank you for enrolling in this event. Excellent Excel welcomes you all. For those of you who don't know about Excellent Excel, here's a gist. Excellent Excel is a data analytics firm that solves high impact business problems using data and technology. We provide end to end services in the field of data analytics and data visualization. Our core services include analytics, consulting, and training. Excel Excel presents the popular talk show EiEFreshTalk on its YouTube channel, where it hosts great leaders and subject matter experts in various fields from India and abroad to speak regularly on a variety of topics ranging from Excel to analytics and finance to financial modeling and many more. Some of our past events are Analyzing Data with Power BI by Amit Chandak and Data Visualization and Insights from Power BI by Deepak Singh. We are happy to share the first ever annual gathering of Microsoft Excel Global Community, which is planned from 6th to 9th February 2021, the Global Excel Summit, a 4-day event with 17 plus speakers and 1,000 plus attendees. Learn from the top excellent practitioners in the world, connect with people in all lines of business, and last but not the least, excel with masterclasses. We are proud to share that Excel Excel is associated as a media partner for the Global Excel Summit. Use the promo code Excel Excel and get special prices on various products and courses. Joining us today, we have our speaker for the day, Mr. Nikola Ilic. Nikola Ilic is a BI developer, Pluralsight author, Microsoft certified trainer, and MCSA data analyst from Salzburg, Austria. He is passionate about data analysis, data modeling, and extracting valuable information from raw data in the most effective manner. He has extensive experience in banking business and online gaming industry, combined with broad IT knowledge. Curious by nature, always motivated to learn the latest technologies and tools and work with talented people. He makes music from the data. He is a Power BI and SQL Server addict, blogger, and speaker. He has multi-year experience working with predominantly Microsoft Data Platform, SQL Server, SSAS, SSIS, SSRS, and Power BI. He is also a football enthusiast and a Barca fan. We welcome you, sir. It's a pleasure having you with us. Before we begin, I request participants to join me in welcoming today's speaker with a hi in the chat section. If you have any questions during the presentation, please type them into the question box. We will later present it to the speaker. Over to you, sir.
Thank you for the nice introduction. Hi everyone, and good afternoon or good evening, because it's afternoon here in Austria. Let me share my screen for the beginning. Just a moment. Hope that you can see it now. Okay, so as I said, good afternoon or good evening. Thanks for inviting me to be part of Excel and Excel Fresh Talk series. And I'm really excited to be with you today, and I believe that you will enjoy our session. So today I want to talk about Power BI internals and some best practices to keep your data model size in optimal condition. I believe it's quite important topic from many perspectives. Therefore, I really hope that you will enjoy the session and get some useful takeaways once we are done. Before we start, okay, so I'm already introduced, but just briefly walk through again. So my name is Nikola Ilic. I'm originally from Belgrade in Serbia, but since last 4.5 years, I live in a wonderful city of Salzburg in Austria, where I work as a BI developer at company ITSP Services. Living in Salzburg was the reason why I've chosen my nickname, Data Mozart. As you probably know, Salzburg is worldly famous as a birthplace of Wolfgang Amadeus Mozart, and I was brave enough to use his last name as part of my nickname. And that's why my motto is make music from your data. I'm regularly blogging at data-mozart.com. I'm also pretty active on LinkedIn and Twitter, so feel free to ping me or connect if you like. A few more sentences about me. I have multiple year experience working with different data products, predominantly with Microsoft Data Platform. Started with SQL Server, then brushed myself with analysis services multidimensional. reporting services, integration services, and most recently, if you consider last 3.5 years as recent with Power BI. I'm also a Microsoft certified trainer, Pluralsight author, and certified data analyst. Privately, I'm a father of 2 little kids and true football and Barca fan, as you can conclude looking at the photo on the slide. Okay, so we can start now. I guess you all know the story about Titanic. If you don't know, you should watch the movie with Leonardo DiCaprio and Kate Winslet. You already probably watched it, so sure, who hasn't? So Titanic was the most powerful, most beautiful, largest ship of all the time. People were in awe looking at this brilliant piece of human's creativity. But Titanic's story was very short. It ended almost before it started. After only 4 days of voyage from Southampton to New York City, in the early morning hours, Titanic hardly hit one of the many icebergs in the Atlantic Ocean. At first look, it didn't seem like something that can transform the greatest engineering achievement into a historical tragedy, when more than 1,500 people lost their lives. However, Titanic didn't sink because it hit the tip of an iceberg. The main culprit was under the surface, in the cold ocean water, where the largest part of the iceberg resided. So Titanic received a shot without a chance to recover, and in less than 3 hours later, it was on its way to the ocean's bottom. Now you're probably asking yourselves what on earth story of Titanic has with Power BI. And just stay tuned, I will show you if we think a little deeper. So if we think a little deeper, we can think of Power BI as an iceberg in the cold ocean's waters. Tip of iceberg is your Power BI dashboard or the report itself. And that looks, I would say that looks beautiful, like a snowy mountain straight in the middle of the water and under this awesome blue sky. All tourists look with admiration in this piece of art of the nature. And they're making photos and videos, as they want to enjoy this beauty. But what they don't know is that the real thing is under the surface. So the biggest and the strongest part of this iceberg, which provides stability and steadiness of this visible part. And this part underneath consists of multiple individual but cohesive parts, which enable above the surface part to stand strong and shine. As I said, there are multiple individual portions down there. If you think for a moment here as a Power BI developer, you will see different concepts, architectures, and techniques that makes your Power BI dashboard shine. If you don't understand and apply those concepts on the right, such as data profiling or data modeling or data shaping, in a proper way, your Power BI report will experience the same fate as Titanic. Same applies if you don't dedicate deserved attention to architectures and techniques on the left. Always keep in mind that all these, but also many other more core concepts is what enable your Power BI dashboard to perform in the most optimal way. Therefore, never underestimate the importance of understanding all those invisible things under the surface. Today, we will focus on learning and understanding vertipaq engine, but you should also spend your time learning other key concepts listed here. In the end, you can, of course, create Power BI reports that work without knowing these underlying concepts at all. But there is a huge difference between Power BI reports that just work and Power BI reports that work efficiently. That being said, what are the prerequisites for today's session? This is a 300 level session, which means advanced level. So it assumes that you have some, not just basic, but I would say intermediate knowledge and experience with Power BI and data modeling in general. That being said, I expect from you to have at least basic understanding about relational databases, their structure in terms of how the data is being stored in the database, and to be able to distinguish between rows and columns. Of course, knowledge of Power BI is also necessary to follow along, because I will often refer to some things related to a Power BI development that I assume you are familiar with. Quick intro into agenda. We will learn what is vertipaq, how it stores the data, what kind of algorithms vertipaq applies to compress your data, and how we can help vertipaq to build an optimal data model for us. Finally, we will get our hands dirty and dig deep under the hood of Power BI. During the demo, I will show you on a real-life example how I managed to reduce Power BI data model size by unbelievable 90%, just by sticking with few rules and few best practices that we will talk about today. Okay, so here we are. Before I start talking about vertipaq, I would like to ask you one simple question. Have you ever wondered what makes Power BI so fast and powerful when it comes to performance? So powerful that it performs complex calculations over millions, sometimes even billions of rows in literally blink of an eye. So we will see today how it's done, how your data is being stored, compressed, queried, and finally brought back to your report. And once we are done, I hope that you will get a better understanding of the hard work happening in the background. Okay, going back to our starting point, what is a vertipaq? Again, before we answer to this question, we should mark the line between row store versus columnar databases. Vertipaq is a columnar database. As you can see in this illustration, columnar databases stores and compresses data in a whole different way compared to traditional row store databases. Columnar databases are optimized for vertical data scanning, and they're being used in large analytical systems. That means that each column is structured in its own way and is physically separated from the other columns. Another important distinction in order to understand what is vertipaq is to understand the difference between formula engine and storage engine. Formula engine accepts the request. You can see on this illustration taken from the book Definitive Guide to DAX from Marco Russo and Alberto Ferrari. Formula engine accepts the request, processes it, generates the query plan, and finally executes it. Storage engine pulls the data out of tabular model to satisfy the request issued within the query generated by the formula engine. Storage engine can work in two different ways in order to retrieve requested data. I'll zoom it a little bit so you can see better. The first is vertipaq engine, which we will talk about today. Vertipaq stores a snapshot of your data in cache memory, and this snapshot can be periodically refreshed directly from the data source. On the other hand, direct query doesn't store any data. It just forwards your request direct to data source for each single query. So let's talk about Formula Engine, and you will see how this works in reality. Formula Engine represents brain of Power BI. As I already mentioned, Formula Engine accepts the query, and since it's able to understand DAX and MDX also, but it is out of the scope of this session, it translates DAX into a specific query plan, and that query plan consists of physical operations that need to be executed in order to get results back. Those physical operations can be joins between multiple tables, filtering conditions, or aggregations. It's important to know that Formula Engine works in a single-threaded way, which means that requests to storage engine are always being sent sequentially. So let's reiterate once more through the whole process within Formula Engine. The first step is that Formula Engine accepts the requests, then it will process your request. Next in the line is generating query plan for the request, and finally it executes the query plan. Once the query being generated and executed by the Formula Engine, storage engine then comes into the scene. Since it physically goes through the data stored within the tabular model if you use vertipaq engine, or goes directly to a different data source like SQL Server, for example, if you are using direct query storage mode, we can think of storage engine as the muscles of Power BI. When it comes to specifying the storage engine for the table, there are three possible options to choose from. These three options are import mode, direct query mode, and dual mode. As opposed to Formula Engine that doesn't support parallelism, storage engine can work asynchronously. Let's now talk about these three possible options for storage for data storage for specific tables. So first one is import mode, and this is the most common way to store data when working with Power BI. That being said, the import mode is based on vertipaq, and table data is being stored in memory as a snapshot, and data can be refreshed periodically. Frequency of data refresh depends on your business scenario. It can be every 30 minutes, every hour, once per day, once per week, once per month. It really depends on your specific use case. When you're using direct query mode, data is being retrieved from the data source at the query time. That means that data resides in its original source before, during, and after the query execution. Finally, dual mode is just a combination of the previous two options of import mode and direct query. Data from the table is being loaded into memory, but at the query time, it can be also retrieved directly from the source. As we've drawn a big picture previously, let me explain now in more details what vertipaq does in the background to boost performance of our Power BI reports. So when we choose import mode for our Power BI tables, vertipaq will perform the following actions. Excuse me. First, it will read the data source and transform our data into a columnar structure. Then it will encode and compress data within each of those columns. After that, it will establish dictionary and index for each of the columns. Then it will prepare and establish relationships. And finally, it will compute all calculated columns and calculated tables and compress them. How vertipaq stores the data? As you may recall from the previous part of our session, two main characteristics of vertipaq are that it's a columnar and in-memory database. So vertipaq applies different types of compression to each of the columns independently, choosing the optimal compression algorithm based on the values in that specific column. Compression is being achieved by encoding the values within the column. But before we go deeper into a detailed overview of different encoding techniques, just keep in mind that this architecture is not exclusively related to Power BI. In the background is a tabular model, which also works under the hood of analysis services Tabular and Excel Power Pivot. So let's examine the encoding types which vertipaq applies in order to compress our data. First is value encoding, then hash encoding or dictionary encoding, and finally RLE, which is abbreviation of run length encoding. Now we will go into more details regarding each of those encoding types. And first one is the value encoding, which is the most desirable encoding types since it works exclusively with integers. Therefore, when working with integers, it requires less memory than, for example, when working with text values. How this looks in reality. Let's say we have a column containing a number of phone calls per day. And the value in this column varies from 4,000 to 5,000. What the vertipaq would do is to find the minimum value in this range, which is 4,000 in our example, and set this value as a starting point. Then it will calculate the difference between this value and all the other values in the column and just store this difference as a new value. If you look at this example, you can see that we preserved 3 bits per one row. And at first glance, 3 bits per one row might not look like a significant saving, but just imagine that this table has, I don't know, 50 million rows or even more than that, and just multiply with 3 bits per one row. And I think you will appreciate the amount of memory saved using value encoding. Next is hash encoding, which is probably the most used compression type by vertipaq. Using hash encoding, vertipaq creates a dictionary of distinct values within one column, and afterward replaces real values with index values from the dictionary. As you may notice in our example, vertipaq identified distinct values within the subjects column, then built a dictionary by assigning indexes to those values, and finally stored index values as pointers to real values. I assume you're aware that integer values require way less memory space than text, so that's the logic behind this type of data compression. Additionally, by being able to build dictionary for literally any data type, vertipaq is practically data type independent. And this brings us to another key takeaway. No matter if your column is of text or big integer or float data type, from vertipaq perspective, it's all the same. Vertipaq needs to create a dictionary for each of those columns, which implies that all these columns will provide exactly the same performance, both in terms of speed and memory space allocated. Of course, if we assume that there is no big difference between dictionary size between those columns. So it's a myth that the data type of the column affects its size within the data model. It affects dictionary size, but not column size itself. On the opposite, the number of distinct values within the column, which is known as cardinality, mostly influence column memory consumption. Finally, third algorithm, run length encoding, creates kind of mapping table containing ranges of repeating values, and in that way avoiding to store every single repeated value separately. Again, taking a look at the example will help to better understand this concept. In real life, vertipaq will not store this column. I put it here just for the sake of clarity to better understand the concept, but this column doesn't exist in reality. The only thing vertipaq stores is these count values, because it can quickly calculate where the next node begins just by simple summing all previous values. However, as powerful as it might look at first glance, RLE algorithm is highly dependent on the ordering within the column. So if the data is stored the way you see in our example, so you see here I have many repeating values, then another bucket starts with repeating values, then another one. In those situations, RLE will perform great. However, if your data buckets are smaller and rotate more frequently, then run length encoding will not be an optimal solution. One more thing to keep in mind regarding RLE, in reality, it always comes after hash encoding. So vertipaq will first perform hash encoding and create a dictionary of the subjects, and then it will apply run length encoding algorithm. So the final logic in its most simplified way, of course, would be something like this you can see on your screens. So basically, run length encoding occurs after hash encoding in those scenarios when vertipaq thinks that it makes sense to additionally compress the data. So when the data is ordered in that way, that run length encoding would achieve better compression. Let me just briefly iterate through the process of data compression for a specific column within Power BI. So vertipaq scans a sample of rows from one specific column, and if the column data type is not an integer, it will look no further and it will use hash encoding. On the other hand, if the column is of integer data type, some additional parameters are being evaluated. So if the numbers in this sample linearly increase, vertipaq assumes that it is probably a primary key column and it will use value encoding. On the other hand, when evaluating value range between integers in the column, if the numbers in this column are reasonably close to each other, so number range is not so wide, like in our example with 4,000 to 5,000 phone calls per day, vertipaq will use value encoding. On the other hand, when values fluctuate significantly within this range, for example, between 1,000 and 1 million, then value encoding will not make sense and vertipaq will apply hash algorithm. However, and that's important, no matter how smart vertipaq is, it can also make some bad decisions based on incorrect assumptions. Therefore, sometimes it can happen that vertipaq makes a decision about which algorithm to use based on the sample data, but then some outlier pops up and it needs to re-encode the column from scratch. Let's use our previous example for the number of phone calls and just imagine this situation. vertipaq scans the sample and sees that values goes from 4,000 to 5,000 in this sample. And vertipaq chooses to apply value encoding. Then after processing 10 million rows, all of a sudden it found 500,000 value. It can be an error or whatever. Now vertipaq will reevaluate the choice and it can decide to re-encode the column using hash algorithm instead. Obviously, that would impact the whole process in terms of time needed for reprocessing. Here is the list of parameters in order of importance that vertipaq considers when choosing which algorithm to apply. First, as already mentioned, is number of distinct values in the column, which is known as cardinality. Then data distribution in the column, which means that column with many repeating values can be better compressed than one containing frequently changing values, because as you already saw, run length encoding can be applied on top of hash algorithm. Next is number of rows in the table, and finally column data type, which impacts only dictionary size. Okay, I believe we laid now a solid theoretical background for the things that come now. So it's time to get our hands dirty and see how all of this works in reality. Before we start, I just want to emphasize that this demo is based on a real use case which I faced during the last year. The problem was with the size of PBIX file on our report server. File size dramatically grown since the report had been introduced, so I was involved in trying to find a solution. And just to stress one more thing before we proceed further, for this demo I've created 4 separate PBIX files, each of them representing one single phase in the data model size optimization. I did that so we don't need to work on one single file during the demo and wait for Power BI to apply all changes we made during the process. As in some cases, as you probably know, it takes a while to reload the data and recreate the data model. Okay, so I will now show you starting PBIX file. I've just put a plain card visual showing total number of records in our fact table in all of these 4 PBIX files. So you can see that data accuracy is not being violated by applying various development steps. I slightly simplified data model for our demo. You can see here that I have my fact chat table, which contains data about chats that our customer support department performed with the customers, and 2-dimension table. So it's simplified. And as you can see here, if I go to my fact table, let me zoom it a little bit. So it has around 9.3 million rows. 9.3 million rows, so nothing special in terms of volume. I mean, Power BI should be able to cope with that without any problems. The main thing here is, the main issue is that all tables were imported in Power BI as it is, without any additional optimization or transformation. So just simple check table name and import mode. To be able to follow what is going on with our data model size, I will use DAX Studio. For those of you who are not aware, DAX Studio is a fantastic free tool created by Darren Gosbell, Marco Russo, and Alberto Ferrari. And it has a whole bunch of very handy, useful features that I would need another 60-minute session just to talk about it. In any case, if you're working with Power BI on a day-to-day basis, you should definitely start using DAX Studio. Believe me, it will make your life much, much easier, and it will boost your productivity. Okay, so I can connect to DAX Studio directly from Power BI Desktop. If I go to this External Tools tab, of course, prerequisite is that you have DAX Studio installed on the same machine as your Power BI Desktop. So I can click on DAX Studio, and it will automatically open and connects me to my instance of Power BI Desktop. Before we proceed, just basic introduction to a tool. On the left side, you see here, you see all tables from your data model. If you don't know, if you're confused with these local date tables and bunch of weird characters after that, these are automatically created date tables in Power BI Desktop. We will come later to this. I will explain everything. Just wanted to show you here on the left-hand side, you see all your tables. Okay, so one of my favorite features in DAX Studio is a vertipaq analyzer tool, which will help us to see the numbers behind our data model. Okay, so before I launch vertipaq analyzer tool, let me just show you one thing. Let me go here. Okay, so this is our starting point. 771 megabytes. I want you just to remember this picture, or just this number. You don't have to remember the picture. So we are starting with the 771 megabytes. It's pretty massive. But I lied to you. That's not the whole truth. The truth is even worse. It's not just 771 megabytes that burns our memory. Since memory consumption is being calculated taking into account not just PBIX file size, but also dictionary size. You remember we talked about dictionary while explaining hash encoding. Then column and user-defined hierarchies and relationships between the tables. Okay, so let's go finally to vertipaq analyzer. I'm going to advanced tab here on the top, and I will click view metrics. That will launch vertipaq analyzer. And here you can see all your tables, and you see different metrics for your tables. just quick introduction. So you see the maximum cardinality of the table, size of the table, all those numbers are in bytes, just for your for easier calculation for you. And you can see how much in terms of percentage each single table occupies in your data model. Now, if we go to this small arrow next to a table name and click on it, I see all those numbers broken down by a column. So I see which columns are the most expensive in my table, and I can see the size of the column. And let me just show you. So column size is just a simple sum of these three values. So data size, dictionary size, and hierarchy size. Also, you can see which encoding type vertipaq performed for a specific column, so hash or value, and you can check if that works fine, as we talked earlier. Okay, so let's go through, and I will show you now one more thing. So if I go to Summary tab, I will see that total size of my data model is 1.86 gigs. So it's not just 771 megabytes, because it's just PBIX file size. When all other things come into the place, we have data model size which is 1.86 gigs, and that really hurts. That's obviously too much. So let's see what we can do to optimize our data model. And let's take a look at our most expensive table, which is a fact check table. Okay, so first thing I notice here is that I have two columns with highest possible cardinality. So source ID and chat ID. Chat ID is just a surrogate key from my data warehouse, and source ID is just a primary key from the source system. So in any single scenario, I don't need both of them. Probably I don't need neither from them, but in any scenario, I don't need both of them. So let's get rid of this source ID column and see what happens with our Power BI data model. So I'm going to Home, Transform Data, and once I'm in Power Query Editor, let's go and exclude this source ID column. So remove column and hit close and apply. We will need to wait a few seconds for Power BI to apply those changes. Okay, and we will check Index Studio. I will again click on View Metrics, so my connection will be refreshed. Okay, and now if I click on Summary, I can see that it's now 1.54 gigs. So just by eliminating one unnecessary column, we get rid of 300 megabytes of space. And let's go back and check what other columns are the most expensive ones. So I will sort them. You can sort all those metrics according to your needs. So if I check now, I see two date TM columns, both with very high cardinality, both very expensive, and both go to a second level of precision. One, this date TM start, is original time when chat started in original time zone, and the other one is this exactly the same value converted to UTC. So I don't need both of them. I will keep UTC column, so later in the report I can do some transformation calculations to another time zones if necessary, but I will get rid of original date TM start. Other than that, also these two columns, session referer and referer, are also very expensive. Both have cardinality greater than 1 million. I check with my users and they don't use these columns for any kind of analysis or calculations. Additionally, this chat variables column, also very expensive because it works with text values. It's just a bunch of JSON records imported as it is without any transformation. So even if someone needs them, they're not usable in this existing state. Other than that, last added date is that's an information when my record was last time updated in data warehouse. So I checked with my users and they didn't even know that this column exists in data model. So let's go back to Power BI and get rid of all of those columns again to transform data. And let's see what happens when we remove those columns, because we definitely don't need them in our data model. I will go back to my fact table and let's get rid of date team start. Then next one is referer, then session referer. What else we identified? Last edit date and chat variables. Sorry. Let me go from the beginning. So date team start, then referer, session referer, then last edit date, and finally chat variables. Okay, I will remove those columns. And once I hit close and apply, let's wait another few seconds for Power BI to apply those changes. And we will go back to DAX Studio to see if that brought some additional savings. I mean, it definitely brought, but let's check how big. Okay, so it takes sometimes a little bit longer. That's why I created different PBX files so we can work separately on each of them. Okay, so let's wait a few more seconds for Power BI to create a connection. And we will check in DAX Studio. So highly recommended tool for usage. If you're working with Power BI, you should definitely check DAX Studio. It will really help you. There are also some other cool external tools like Tabular Editor also for some advanced stuff, but yeah, it's ready. Let's go back and click on View Metrics. And now if I check in Summary tab, I can see that my data model size is now 660 megabytes. So we shrinked 2/3 of the size of our data model just by removing few unnecessary columns. And true to be said, in this fact chat table, there are some few more columns which could be dismissed from the data model, but let's now focus on other techniques for data model optimization. As you may recall from the previous part of our session, when I was talking about the order of importance of parameters that affect the model size, I mentioned that cardinality is number one, so number of distinct values within the column. And the rule of thumb is the higher the cardinality of column, so the more distinct values in it, it's harder for vertipaq to optimally compress the data, especially if we are not working with integer values. So there are multiple techniques for reducing column cardinality, and the most popular one is column splitting. I will share with you now a few examples of using this technique. Just let me first show you in slides how it's done. If you're working with integer columns, so you can use division and modulo operations, and how it will look like. Instead of having one column with high cardinality, we will split this column in two different with lower cardinality. Similarly, if you work with decimal columns, you can split them before and after the decimal point. So you have two whole number columns with lower cardinality than the original one. Similar to that, if we are dealing with date time values, we can split them to date and time values separately. That would also reduce the cardinality. Just one important remark here, if you think of using calculated columns to apply data model size optimization techniques, there is no benefit at all, since the original column still has to be stored in the data model at first place before your calculations are being applied. Basically, optimization techniques must be performed on the source side, in most cases by writing T-SQL statement or within Power Query Editor. Of course, if you're writing T-SQL, if you're writing custom T-SQL code to import the data in your Power BI data model, just keep in mind that you should perform all necessary transformations in your T-SQL logic, as the query folding would be broken if you use custom T-SQL query, and afterward apply additional transformation steps in Power Query Editor. Okay, so I will now show you how it's done in T-SQL. So how can you reduce the cardinality? Using division and module operations, as already mentioned, instead of having one column with high cardinality, we are getting two. This one has cardinality of 1. This has higher cardinality, but you saved, instead of having seven characters, you have 3, so you save a few bits per row. And if you multiply this with I don't know, 50 million or 100 million rows, yeah, that's significant saving. Also, splitting decimal column to 2 whole number columns works like this. You see, also reducing cardinality. And finally, if you're dealing with the date time, you just cast your date time column to separate, to isolate date part in one column here and time part in the other column. So that will also reduce the cardinality. Okay, so of course, these techniques would require additional effort in the report itself and rewriting your measures to return the correct results. So be careful when to use them. We will examine this in the closing part of the session. I just wanted you to be aware that these techniques exist and they can bring significant benefits in some specific scenarios. Since we are not dealing with decimal values here, let's focus on our exact problem, and that's our, let me sort again, that's our date TM start UTC column. It has cardinality of almost 9 million. There are multiple valid options to optimize this column. The first is to check if your users need granularity lower than day level. In other words, can we remove hours, minutes, and seconds from our data model? Of course, I made a mistake and I didn't ask my users, so I just removed this time part, and let's see what happened with our data model. So that's the second PBIX file. Thing I did here, I will show you now. In fact table, date TM start UTC. Here you can see that I have this time part, and once I switch my type from date time to date, that's already done, this time part disappeared, so it's removed from data model. And if we connect to DAX Studio from this PBIX file, and let's check now the size of data model, going to advanced and view metrics. Okay, if we go to summary, it's 213 megabytes. So we started with 1.86 gigs, we are now at 213 megabytes. So it's approximately 15% of our starting point. That's huge. That's huge. But of course, it appeared that day level grain was not fine enough, and my users needed to analyze figures on hour level. Okay, so we can at least get rid of minutes and seconds, and that would also decrease the cardinality of the column. So how it's done? I wrote a T-SQL query to bring back data to my Power BI. How is with using date add and date diff built-in functions. Let me show you how it looks like. So all chats that started between 3:00:00 and 3:59:59 were rounded to a starting hour. So all these chats belong to 3:00:00. And now if I go back to this PBIX file where my values are rounded per hour, and if I go to not transform data, because we already saw how it's done, we can close this. And if I connect to DAX Studio from this PBIX file, let me check how this affects numbers. So going to advanced, view metrics, and in summary, 221 megabytes. So 8 megabytes more than in previous case, but still 400 and something megabytes less than when we had on a second level precision. And now if I look to my fact chat table, and let me find date TM start UTC here, instead of almost 9 million cardinality, now I have 32,000, which is way, way, way less. And that column is now very, very good optimized. Okay, so one more thing bothered me here. So this chat ID column, which is just a surrogate key from data warehouse, and it occupied almost 1/3 of my whole table. The thing is, here you see that I have a lot of columns with this ID suffix at the end. So IP address ID, customer ID, user ID, etc., etc. Just one thing to keep in mind here. So we can't remove all those columns with ID suffix. These columns like IP address ID, customer ID, user ID, these are foreign keys to our dimension tables, and they are part of relationships in our data model. So these columns can't be removed because we will violate the data model integrity. But this chat ID column, as I said, is not part of any relationship, not any calculation in the report. So why on earth should we keep this in our data model? And let me show you once this column was removed from the data model. I'm going again to external tools, DAX Studio, and let's check now the numbers. So if I go to advanced view metrics and go to summary, it's 161 megabytes. So if you compare our starting point, which was 1.86 gigs, with the current 161 megs, I'll let you do the math. So I didn't lie when I said that I managed to reduce my data model size by 90%. One last step to do in order to optimize our data model is to disable auto date time in options for data load. So these, when I promise that we will come later to this strange local date tables, let me go back to Power BI. If you're not aware, when you leave this auto date time option checked, it will create a hidden table for every single date field in your data model. So if you have multiple date fields in a table of hundreds of millions or even billion rows, your data model will be bloated with those hidden date tables. What is even worse, these tables search for the minimum and maximum date value in your whole data model and create date range between minimum and maximum value. So if it happens that you have something like December 31st, 2099 for the current records, your automatically created date tables will span until that date, even if you don't have any single record in your fact table that matches that date. Working with dates and importance of having a proper data dimension to handle all your time intelligence calculations should be, of course, topic of separate session. I just wanted to give you a quick heads up why you should consider disabling auto date time for your Power BI desktop files. How it's done? Go to File, Options and Settings, Options, and under Data Load, you see this time intelligence. By default, it's checked. So I will uncheck this now and click OK. And here is another handy use case of DAX Studio. You can't see these hidden tables anywhere in Power BI desktop, but if we go back to DAX Studio, and you see that they disappeared from here. So they are removed now. If we click again on View Metrics, it's 157 megabytes. That's our finishing point, final point. So we started with 1.86 gigs, and we are now at 157 megs. As I said, this was a real use case which I faced during the last year. Maybe some of you now think, wait, Nikola, why did you waste our time with all this, blah, blah talk about vertipaq, encoding types, cardinality, etc., etc. What you just shown us is basically just removal of unnecessary columns, nothing special. And I can agree that you are not completely, but almost completely right. But keep in mind that in 95% of cases, when you're performing data model size optimization, simple removal of unnecessary and unused columns will be enough to get your job done. And that should be your starting point when dealing with data model size optimization. In those remaining 5% of scenarios, you would maybe need to apply some more advanced approaches, such as column splitting or cardinality reduction, using some of these techniques I've shown you a few minutes ago. Okay, so to conclude, here is the list of general rules of best practices you should keep in mind when trying to reduce your data model size. The first and most important one, keep only those columns your users need in the report. Just sticking with this one single rule will save you an unbelievable amount of space, I assure you. As you've just seen in our demo, sticking with this one rule helped us to make astonishing savings. Try to optimize column cardinality whenever possible. The golden rule here is test, test, test. And if there is a significant benefit from, for example, splitting one column into two or substituting decimal column with two whole number columns, then do it. But also keep in mind that your measures need to be rewritten to handle those structural changes in order to display correct results in the report. So if your table is not so big, or if you have to rewrite hundreds of measures, maybe it's not worth splitting the column. As I said, it depends on your specific scenario, and you should carefully evaluate which solution makes more sense for you. Same as for columns, keep only those rows you need. For example, maybe you don't need to import data from the last 10 years, but only 4 or 5. That will also reduce your data model size. As I said, talk to your users, ask them what they really need before blindly put everything inside your data model. Aggregate your data whenever possible. That means fewer rows, lower cardinality, so all nice things you're aiming to achieve. If you don't need hours, minutes, or seconds level of granularity, then don't import them. Aggregations in Power BI and generally in Tabular model are a very important and wide topic, which is out of the scope of the session. But there are some really awesome resources on the web, and I can strongly recommend reading a blog series on creative aggregations from Phil Simark on dex.tips. Avoid using calculated columns whenever possible. Calculated columns are not being optimally compressed. Instead, if you need to perform some calculations, try to push all calculations to a data source, like SQL database, for example, or perform them using the Power Query editor. Use proper data types. For example, if your data granularity is on a day level, there is really no need to use date time data type for these columns. In those situations, plain date data type will be completely fine. And finally, disable auto date time option for data loading, as this will remove a bunch of automatically created date tables in the background. Okay, folks, looking forward to hearing your questions. Just one thing from my side, in case that there is not enough time to answer all of the questions, or if we don't know the answer right now, I will try to collect them and post the answers on my blog or something like that. So feel free to ask a question. I will stop sharing my screen so I can see the chat window.
Thank you, sir. We will now go ahead and take some time for questions. Just a reminder, participants, please be sure to type your questions into the question box.
As far as I see in the chat window on YouTube, there are no questions at the moment.
Yes, sir. As time goes, people will start putting their questions. So it need not necessarily be today, but over the time they will start putting some questions.
Okay, I will check. I will check then, maybe later, or if someone has a question.
Yes. Sure, sure, sir. So until then, thank you, sir, for the informative session. And on behalf of Excel and Excel, I thank you for sharing your wisdom.
Thank you very much for inviting me. Hope that everyone enjoyed the session. Thanks for Thank all of folks who attended the session, and I hope that you enjoyed it, that got some better understanding of what is going
Yes,
on behind
yes,
the scenes in Power BI. And I also hope that while watching demo, you got some inspiration to optimize your own Power BI data models. Trust me, it's not so
definitely.
complicated. Just simply follow the rules from the session summary, that these best practices from the session summary, and I assure you that your models would be much better fit for your reports.
Yes, sir. Thank you, sir. It was truly very useful for us. So, thank you.
Okay, thank you all. Stay safe and enjoy the rest of the day.
Yes, same to you, sir. Thank you. Have a
Thank
good
you.
day.
You too. Bye bye.
Bye bye. An announcement for all. Excel is glad to inform that we are conducting a learning course that will help you upskill yourself and will help you become indispensable during these trying times. EIE Learning is a set of handpicked online courses conducted by working professionals, curated on a gamut of subjects starting from Tally to Excel and analysis to Power BI. Some of our upcoming courses are: we have a course on Microsoft Excel Essentials, a 20-hour course starting from 7th December. We have a course on Tally Prime Essentials, an 18-hour course starting from 14th December. And we're also offering a course on Customer Analytics and Power BI, a 14-hour course starting from 14th December. Interested participants can register from the link displayed on the screen. An announcement for all regarding our upcoming Fresh Talks. On 18 December, we have a session on dynamic measures and disconnected tables in Power BI by Ajay Kumar. And on 24 December, we have a session on data storytelling using Power BI by Pranjal Dubey. Thanks again for joining us today, and we will see you in our next session. Do not forget to like the video, and for more updates, subscribe to our channel. To know more on EIE Fresh Talk, use the link in the description below. Stay tuned for more Fresh Talk. Have a happy weekend, and thank you all.